Alright, this is our final project for a water valve that's being controlled by a S7 Siemens PLC using a PID loop. What we have here is the PLC itself. We have some analog inputs from the water flow meter. We have some outputs to the actual valve itself that controls the water flow. We also have these two wires going to the potentiometer, which we're using as a set point. The resistors are there to limit the current. And this is just the power supply. It's all being controlled through Ethernet, so hence the hub and all the network ports. This is our flow meter, and this is the connection going to the water valve. The water just flows into that basin and gets dumped. So as the valve turns on, the flow meter measures the flow, sends that back to the PLC, and the PLC uses that to adjust the valve so that the flow rate matches what is preset in the PID loop by that potentiometer. Okay, here's our HMI. So the auto mode controls basically it reads off potentiometer and goes through the PID loop and controls the process variable using the set point that's set by the potentiometer. The manual mode just controls the output to the valve directly. It bypasses the PID loop and everything, so all we'll see here is just the process variable because we're directly controlling the valve without any input from the PID or the PLC. And then the local set point is basically using the PID loop, but it's ignoring the potentiometer setting. We're actually inputting the value directly using these up and down arrows also. So for example, when it's in auto mode, if we turn this up, we can see that the set point is increasing, and you can hear that the valve is opening, and the PLC is going to try to basically adjust the process variable and open the valve far enough so that the process variable is approximately the same percentage. I think it's good. Alright, so then say if we just shut it down, we can go to local set point. Well, now our potentiometer does nothing, but if we go and push up here, we can see that our set point is increasing because these buttons are physically inputting a higher value into the set point. And it's the same idea, the PLC will try to adjust the flow to match the set point. And when we go to manual mode, it doesn't really matter what the set point is. We can actually just control the output of the valve directly. We can shut it down completely or turn it up. And if you put it back into auto mode, it's just going to go back to whatever the pot setting was. So that's our implementation on the HMI. Now for the logic, you can use Jonathan there. Yeah, sure. Show you can see here we got two blocks. We got the main block and the cyclic interrupt. OB30. That's where our PID loop is. It's there so that the PID isn't called every cycle. Now what we got here is basically the PID loop itself, and you can see there's a set point, inputs, outputs, and the state. Those are the main variables that we're using. The set point is the calibrated output from the potentiometer. The input is FT is the flow input from the valve or the flow meter, and the output is the output to the water valve itself. And then at the top we have an examine off contact That's basically to disable the PID when we're in a strictly manual mode. We also have states, and that needs to be set to the proper state for the PID when, depending on what state you're running. So if it's an auto mode, why don't you put your mouse over there? No, back to PID. Yeah. If you hold your mouse over it, it should show you eventually the numbers that correspond to different states. We used automatic for the auto mode and 0 for inactive. So now if we go to our main function block, or main loop I should say, what we got here is a block that calculates the input from potentiometer and scales it so it's from 0 to 100, because our HMI expects to have 0 to 100. So instead of 5,000 whatever something to 25,000, which is the analog conversion, the potentiometer voltage, we want to make sure that it's going to be between 0 and 100 regardless of what setting. Then next we have calibration of the output, which we're taking from the analog input of the flow meter. So the flow meter is supplying voltage to the PLC, which is then converted to a number, and we're scaling that to be also 0 to 100, and that's our process variable. That's where that number is coming from. And then down here we just have some logic that essentially this is the logic that allows us to control a local set point by adding a number to the scaled pot value, which came from above. So when this is active, it actually disables the actual potentiometer input and calculation. It instead takes the scaled variable and just adds to it. Then we have some cleanup right here, which is if the potentiometer reading, because potentiometers are not always that accurate, sometimes you might actually, after scaling, get below 0 or above 100. And this logic here makes sure that nothing does that. So it'll always be between 0 and 100. Let's see what we got here. Then this is the states, and we're basically, depending on what state we're in, we're moving those numbers into the PID state variable, which is something we talked about earlier. These addition blocks here are also for, they work in a similar manner as the scaled pot, or the local input, but they're adding to the output directly. So this is our manual mode when we're bypassing the PID. We're essentially just adding to the output number, which controls the flow valve directly. So it's increasing the number, and the valve opens, decreasing it, and it closes. And all these contacts are there to prevent other modes from being active during that. Is that it? Alright, we're going to use a different camera because our other one died. But before you can actually run your PID, you're going to have to tune it. And the way you do that is to go to the technology object and click on the PID compact object, which matches the name of your PID loop. So ours was PID compact 6, so here it is. Then you have commissioning over here. Double click that, and this is where you start your tuning. You want to control the mouse there, John. You turn the set point to somewhere where normally you want it full, but you're going to kind of set it in the middle. And then you hit start. And you see there the PLC is going to try to calibrate itself. It's going to set the input and output. And after a while, no, you're not going to go there. Hit the start button. Alright.
it. I think it should eventually change to start, right? After it runs for a while. Just go ahead and hit stop. Okay. You're gonna get this prompt. You say yes, and we're gonna turn off our set point. You're gonna want to upload the PID parameters. That's your calibrations, and then you can go to the PID parameters and see what they are. These are what we put in, so they may not, in fact they will probably not match what you have. Go back to basic settings there. No, right there. One thing is, make sure that your PID settings all match whatever process you're trying to control. There's a bunch of pull down menus here. This actually should have been done first. Once it is, then you can make sure that process that you're trying to control is what the PLC thinks it's trying to control. Alright.
Alright, before you can actually run anything, you need to commission the PID block. And you go to the technology objects, which is right there. And you see there's two names. That's because this is actually PID block 6. So technically 5 was the prior one that we worked with. So you need to go into 6 or whatever you call yours, and then go to commissioning. When you double click that, you're going to get this window, and that's basically where you do your tuning of the PID block. You're going to have to turn your set point to, normally you want it to open all the way, but our particular valve doesn't actually reach the full 90% or 100%, so we're just going to set it at somewhere towards the middle. And then you start the tuning by hitting the start button. And then you see there the PLC will do the rest kind of on its own. And down here, it's going to try to match your set point to your output. Okay.